And good afternoon, Four Sigmas here. This is Alex. Today we're going to be doing the 5B Capacitance Lab. Now, a couple things we're going to set up real quick is in our 850 interface. If you don't already have the electrometer set up here, we're going to click on that A analog port, scroll down, and click on the electrometer. And one more thing. We're going to select, you're going to make a user-entered data called separation in centimeters, and you're going to pre-populate it with these values because we're going to be moving the movable plate on our capacitor to these different separations. Now we're going to use keep mode if you're not already in keep mode. Starts in continuous mode, you just click on there, go to keep mode, and that lets you preview your data points and keep it when it's where you want it. So I'm going to start previewing my data points right now. Now what we're going to do is we're going to start it at 0.3 centimeters. Tony, my lab partner, is going to ground the capacitor first. So we make sure we're close to 0. 0.2, close enough. And now he's going to charge the movable plate to 30 volts. And that's close enough. Now we're going to move it to a separation of 8 centimeters, and then he's going to move away, and I'm going to record this data point. Now we're going to move it into a 7 centimeter separation, and he's going to move away, and once it stabilizes right about here, we're going to keep that data point. Move it into a separation of 6 centimeters. Once it stabilizes, right about, we'll call it right about there. We're going to move it into 5 centimeter separation. Tony's going to move back. We're going to wait for it to stabilize right about there. Going to move to 4 centimeters. And wait for it to stabilize. Looks good right about there. 3 centimeter separation now. And of course we wait for it to establish an equilibrium right here. I'm going to move to 2 centimeters. We're going to go and wait a little bit. Right there, we're going to keep that one. Going to move to 1 centimeter. And you guys can see on the graph, every time Tony goes in to move the movable plate, we actually get some stray capacitance. And we're going to wait for this one to stabilize at about right here. We're going to move to a separation of 0.5 centimeters. And keep that data point. And now back to 0.3. And theoretically, this should overlap our first data point pretty well. And it's actually a little below it. But it makes sense that we've lost some voltage over the course of the experiment. Now we're going to stop recording our data, and we're going to exclude this first pair of values. And so now we have our curve, and your professor will provide you with the analysis portion of the lab. We're just going to go over, we just did go over, how to collect the data in Capstone. And if you're just coming from our last video, this is the 4 Sigmas, Alex here, and we're going to do the second part of our capacitance lab using a dielectric. Now we're going to load paper between the plates of our parallel plate capacitor. We're going to do a 6 centimeter separation on the plates and load about 1 to 2 centimeters of paper in between the plates. Now we want to make sure that this paper doesn't touch the plates, and the assignment will be to pretty much observe what happens to the voltage and why. And you're going to compare it to the 6 centimeter separation using air as the dielectric. So we're going to start previewing our data right now, and we're going to ground the system first, and then we're going to charge 2 plus 30. We're going to keep that, and then we're going to insert our paper dielectric between the plates. And as you can see, our data is going up and down in terms of voltage because we're using a different dielectric. So your job is to figure out why. Pretty simple. And you guys will go over this in your lecture. So again, with the dielectric and without. So thank you for watching, and we'll see you next time.